Okay, this one. Okay, these two can find out this magnet is done by steel bar. We use steel bar to do the magnet. Iron cannot. Yeah, we cannot use iron. Cannot use aluminium. Cannot use copper. Copper used in wire. Okay, now we go to see the electromagnet. What is this? This is a conductor. Okay, current flow through conductor. It will produce magnetic field itself automatically. So this one we so-called electromagnet. Okay, we see one by one. First is straight wire. The direction of current, one up, one down. Then this one use your right hand grips rule. Okay, your thumb will be current. Others curved finger will be magnetic field. You may take a pen, then your right hand grabs around it. Then you will see it will curve clockwise or anti-clockwise. And the pattern actually is circle, but when we draw in 3D diagram, we draw in ellipse. Because we draw in 3D, so become ellipse. But actually is circle. Circle. Okay, then check the clockwise or anti-clockwise. This one is your current upwards, current downwards. So your hand, right hand must use right hand, point up and down. Okay, so this one will see is anti-clockwise. Then this one will be clockwise. This one is single straight wire. This one is two wire near to each other and interact each other. Then later we will see the catapult force. Okay, how to find this? Okay, like this. First, draw two circles also. Then draw what? The direction of magnetic field. Both are anti-clockwise. Because magnetic field line cannot cross each other. So you see the middle. These two are different direction. So cannot. So we need to find where is the same direction. Same direction will be here. You see, this one go to right. This one go to left. This one go to left. So they will combine like this to become number of 8. Become number of 8. So middle of the two wire will be less field. The both side will be larger field. So catapult force will make them attract. Okay, because this one is strong. Inside here is weak. Like rubber band. Make them near to each other. So this one got force. So they will attract each other. The current in different direction. One clockwise, one anti-clockwise. Then you check at the middle of them. They are same direction. So same direction. At the middle, they can combine like this. Combine. And then in between is curve. Wow, curve. But cannot touch. Not yet. Then one more circle here. Wow, so nice. So now where is strong? In between will be strong. You see, so near each other, all of them. Outside will become weak. Very weak. So the wire will repel each other's. This is force. This one is force. Force is so-called repulsive force by catapult force, by the magnetic field. Two magnetic field interact each other, produce force. Either attract or repel. Wait, this one, the two different direction wire also can draw like this. Or you can draw like this. So where is your current? The current go in, come out. Go in, go out. Middle here. You see different direction. They are similar. The coil. This one we saw called coil. Then what is solenoid? Okay, this one I give you 4 examples. Actually got 8 of them. But I just give you 4 enough lah. 1 compared with 2, 1 compared with 3, then 1 compared with 4. Then third one, you see, be careful. Third one will be like this. One turn in front first, another one turn at the back first. The way they turn are different. This one, positive here, negative here. Then now change to negative, positive, negative, positive. Be careful how the wire turn, the wire. So affected your result. And then this one also use right hand grips rule. Similar like the straight wire, but your thumb now become magnetic field, which is north. Other curved finger will be current. You can imagine because we have many wire, so the wire represent 4 of your finger. So the 4th finger means the wire turn. After that, label positive, negative. You see the first one, the current flow from positive go to negative. So you need to refer the direction of current in the solenoid. After that, use your hand, right hand. Then you see your thumb put where? This one will be north, this one will be south. Curve in front, then curve to back. Use the pen. You can try use a pen to curve it. Okay. Then second, you see like this. It will turn down. Means your hand need to turn another way. So north will be here. South will be there. What am I talking about? So number third, third and fourth, try. Like this. You see the direction of current change. So first and third, the north and south, reverse it. So 2 and 4 also reverse it because your wire turn different way. And not still have something to draw. You can choose either one to draw the magnetic field. Draw like this, straight line at the middle, curve up and down. Then you will notice that similar to bar magnet. It is bar magnet. Oh, sure. After that, draw ellipse. After that, put the arrow. North is going out, south is going in. So that's why we need to find polarity, because we need to have the direction of magnetic field. Like this. You see, if I cover it, you see, not bar magnet. So solenoid also is a bar magnet, but it's temporary bar magnet. Bar magnet is permanent magnet. This one, when we turn off the current, it will disappear automatically. That's why we so-called temporary magnet. Go to the notes. This is what we draw just now. We can control magnetic field, strength of magnetic field. So first is current. So the larger the current, the bigger the magnetic field. Next is number of turn. The more turn will be more powerful. Okay. Lastly is the iron core. This one I need to explain a little bit. What is iron core? It's iron, okay. And normally we use soft iron. Steel is permanent magnet, okay, because it is hard magnetic material. Okay, what is meant by hard magnetic material? To demagnetize. Iron is soft magnetic material. Okay, so it will be easy magnetize and demagnetize. This is the difference. Okay, what I mean by magnetize? The metal become magnet. So demagnetize, D is disappear. Okay, so magnet become normal metal. Okay, another explanation is like this. Let's say this one is bar magnet. Then here got iron. What happened? Why the magnet can attract the iron? Why? Because iron is magnetized by magnet. Here it will become south, here become north. And then they will attract. This so-called magnetized. We also call magnetic induction. Because the magnet does not touch the iron, but can make it become magnet. So iron very easy magnetize and demagnetize. What is the meaning there? When we take away bar magnet, the polarity will disappear itself. But after we put in the magnet, it will come back. So-called easy magnetize and demagnetize. Okay. So we put in the iron core into the solenoid. It can concentrate the magnetic field. You also can think that the solenoid is one magnet, and then soft iron core become another magnet. So it will become two magnet bar inside. So it will be stronger. So you see outside the magnetic field are further. Go inside the iron core will be closer. So become stronger. So where we use? Actually we use every day. Like the earphone, earpiece, living magnet, electromagnetic relay, electric bell. Okay, it's one by one. Okay, lifting magnet, it can attract very, very heavy things. When we reach somewhere, then we turn off, they will fall down. Okay, in the movie or what, you can see this one, they attract the car. They also can use in recycle factory. Why? Because they can separate them, separate the iron, plastic automatically, very easy. So earpiece, okay, you see this one, the alloy membrane, it will vibrate because the current strong, magnetic field is strong, the force also strong. So when your current supply is weak, so your force also weak. So actually we control the current to control the vibration of diaphragm to make it vibrate and then produce sound. Electrical bell will control the hammer, not on the cone, and vibrate. Boom, 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 boom. Okay. So how it move? Okay, first you see the current flow pass through here, plus two. So here will produce a force attract the soft iron armature. So it will move in. When it move in, this contact will lose, become no current. And then the spring will pull it back and then connect the circuit. So the circuit will be connected, disconnect, disconnect, repeat. So give you the sound, okay? What is the relay? Relay symbol is look like this. One coil and one switch. We so-called relay. Relay switch also can. Okay. How it use? This is more important. Okay, you can connect it. Connect here. Then connect here. Connect here. This one I simplified the circuit. Okay. So here, different from the what I'm talking about. Different from the diagram. Okay, this one is power supply. Okay, this one is power supply. Power supply. Why got two switch there? This is the more important things. Machine. See, got two supply. And then where is your hand? Your hand will put here to turn on. After that, this one, I change color. Then your solenoid will be magnetized. After magnetized, it will attract the switch to turn on. After that, your machine will on. The problem is come in. Why so troublesome? Why our hand don't turn on directly? Go to turn on here. Why? Why so troublesome? Because for safety. Where I can put safety purpose. Okay, because you see here, the battery is small current. So our hand controls small current to switch on big current. So when it have short circuit or anything leakage of the current, your hand only touch the small current. So electrical shock is very small. So the person will not die. So mostly the big machine, it will have this relay. Inside the car also got relay. Okay, you see the battery here. Turn. One complete already. Complete circuit first is so small, you see. So here will be magnetized. And then your armature will be attract in. Then here will push out. Okay. Then your contact will connected. Then here the power supply can supply the current to the motor. Then turn on. So we use small current to control the big current on.